back and check, right? Check out the videos, check out the worksheets, and so forth. If you are working through that, if you have the workbook, right, and you want more, okay, you want more of those 4 types, there's actually a section that says reviewing all 4. So let me just point you in the right direction if you want more. On page 33, right, on page 33 of the workbook, it says all 4 types review worksheet. I will probably assign that a little later, but if you want to work ahead, then you do it now, right? So just a reminder that our test is this Friday, okay? So, and it's again a long weekend for you. Monday, this upcoming Monday is an in-service, so it seems like you've had nothing but short weeks so far, which is kind of nice. All right. So let's start with it. We're going to just focus a little bit on the vertex form of the quadratic, but really nothing changes. It's still a parabola. You still, you can still use your calculator to type that in, find the vertex. Nothing changes, and really in the grand scheme of things, but there's a few things that are special about the vertex form as opposed to the general form, right? So recall that the general form has no brackets, right? How do you know something is in general form in this unit? You shouldn't have any brackets. As soon as you have brackets, you need to watch out, right? And it looks like this. And so now we're going to talk about the vertex form. It provides you with the direction of the opening, right? So this is still there, and that is still determined by A, right? It still tells you what the width is, right? Actually, both of these are determined by A, just like before. Okay. But this is new, and that's why I tried to capitalize, put caps on it, right? Number of X intercepts and the vertex, okay? So this is new, right? This is new info, okay? And it looks like this. So the vertex form looks like this, and you will notice that there are brackets. Can I ask you to change this to plus? It'll be, in a sense, it doesn't really matter, but let's change that to plus because then whatever I'm doing now with Desmos is going to jive with it, okay? And I'll just repeat that where A determines the direction, right? The direction of opening, right? So that's the first bullet that's going to go there, and then it also determines the width of parabola. And the width is just right. We still go by I'm going to say this, the value of A, right? Versus the direction of opening, that's determined by the sine of A, right? The sine of A, that's the direction of opening. So it still does the same thing as before. A is usually, it's always in front of the x squared term, so to speak, just like before, okay? And the vertex will always be given, you need to change the sign of whatever you have in the bracket. So if it's positive in there, it's going to come out negative h, right, like this. And that negative is very important, right? It changes the sign. Okay. Changes the sign of h from equation. Okay, and I will also highlight that because it's basically I will test you on that. I will ask you, hey, here's an equation. How could you get the vertex just by looking at it? Okay. And we're going to go vice versa. We're going to go back and forth. We're going to extract the vertex from the equation. I'm going to give you a vertex and ask you to write the equation. So we're going to do both things here. Okay. So let me just Desmos, right? By now you should know. If anybody asks you, have you ever seen Desmos? You should say yes, right? So the value A here does the same thing still. I'm gonna do this manually, right? So the closer to 0 you get, the wider it becomes, right? And it's negative. And as soon as you turn positive, right, it will just point upwards. And as the value of A gets bigger, it gets narrower and narrower, right? So it's still the same thing as before. But watch h here, the value of h, which is in that equation. It's kind of backwards. H right now is positive, right? Like, look at the value of h, the sign, right? It's positive. Meanwhile, if I stop right at 5, what's the x value here at the vertex? It's negative 5. So it's like, what's going on there, right? So it's the exact opposite. So if I go to negative 5, okay, that's going to give me a positive 5 here, right? So it does the exact opposite of whatever is in there. And the value of k, watch what k is right now. K is 1. I look at the vertex, right? So right now it's 5, 1, right? So the value of k actually determines the y value of the vertex. So if I have it at negative 1, let's say, watch the y value, right? It is negative 1, which coincides with the value of k. So these two values, the sign stays exactly the same, but when it comes to the x value, it will be the opposite of whatever is in here. Okay, so that's why I wanted that illustration. So here we go. If we look at this, right, you should know that the direction of the opening is down, right? And why is that? A is negative. And then what's the width? This would be, you remember this stuff? It's been such a while. A is equal to 1, right? So this is normal. Why? Because A is equal to 1, right? If you just look at that value there, it is exactly 1. Don't look at the sign, just at the value. The vertex, watch this, folks, right? The vertex, if I look at that, if I bring this out, is going to be negative 4, right? And 5, positive 5. So the sign never changed, but it did change here, right? It was positive 4 in there, it came out negative 4. Okay, and the y-intercept, common mistake. Okay, close attention right now. The common mistake is for students, don't write this down, but they'll do this. Right? Because we've been talking so much about, you know, that constant at the end, that's your y-intercept, but this is not in general form, is it? So you can't do that. So what we have to do is we have to use our calculator for this. Okay, you can't just read it off the, so we're going to go y2 is equal to 0, second trace 5. So let's go ahead and type that in and find it, right? We have to get used to typing this type in. I'm going to turn off, listen carefully, I'm turning off plot 1 because I'm manually inputting an equation. I'm not using a regression. So I'm going to go negative bracket x plus 4 bracket x2, right, for the square. Don't forget that one. And then plus 5 like that. I'm gonna go zoom 6. Think about your vertex is negative 4, 5. So if you go zoom 6, anybody remember what that is? Standard zoom, right? So that's just like a negative 10, 10, negative 10, 10 window. That is good enough. So let's go and make y2 equal to 0. Sorry. Is it Monday? I'm trying to find the X intercepts, right? Let's go back here. I did not mean to confuse you. That was not my intent. Sorry about that. We have to go second, trace 1, x equals to 0. That's what I meant to put down there, right? That's how you find the y-intercept, because the y-intercept is always 0 and a number, right? So x is equal to 0 at that point. My apologies. So second trace 1, x is equal to 0, and there it is. It's negative 11, right? So y is negative 11. I want you to think of it as a point. It's not an equation, right? What you just did is you found a point, which is the y-intercept. And I actually make a note here. I don't know if you see that. Common error. Students think that the constant k is the y-intercept. This is not correct, right? And it is not in general, right? If it's not in general form, we have to use this, right? So that's basically what we did here. I don't know if we just put an arrow to it, and that's what we applied there. Next, this one is going to go up. Why is that? Because a is positive. It's going to be wide because a is between 0 and 1, right? It's between 0 and 1, so it's considered a wider curve. And watch this. I look at I recognize this is in vertex form, so it can give me the vertex, which is unique, and it's going to be positive, right? I don't know if you want to do that, because it's not wrong to say that, right? It's negative in there, comes out positive, and the y value stays the same. Do not change the sign. And we're going to do this again. Second trace 1, x is equal to 0. Okay, let's do that in a little bit. Let's fill out the rest here. This is going to be up because a is positive. It's going to be 2/3 is 0.6 repeated, right? So it's going to be wide because a is between 0 and 1. My vertex is going to be plus, right? 7.92. You don't have to do the plus, but I'm just putting, and what's my y value? 0, right? There you go. Just like my bank account, right? Anyways, then you go second, trace 1, x is equal to 0. So quick, I will just check something here. Can you please find the x-intercept, y-intercepts for both of these? Do that real quick. It involves some windows and making sure you see everything quietly. And if you want to compare and maybe make sure I do it right, because apparently I need some accountability today. That's what I get there. And then you have, I like to put the 2/3 in brackets like that. And then I go x minus 7.92, square that. These all happen to, so I cannot see the y-intercept. I'm not sure if it's going to allow me to find it. I'm going to give it a try. It does. It does. But it's way up, right? So technically, I need to have my y max to 50 or something like that. and then you can actually see it, right? So this would be, I erased it. What is it again? Negative 41 point. It's not negative, it's positive. 41.82. There you go. 41.82. 41.82. There we go. So that's how you find. Please don't fall for it. I'm probably gonna ask you. It's like, hey, what's the y-intercept? And you're gonna be tempted to say, right, 0, -7 or 0, 5. Right? You can't do it if it's in. If you see brackets, use your calculator for that. Okay. So I guess let me just check the back side here. I'm thinking I might use the bottom here, but if it comes up later, no, it comes up later, so we'll just continue. Okay, so just flip over to the back side here on page 32. And we're going to finish this sentence here. Determine the number of X intercepts. Okay. Determine the number of X intercepts. So this chart, I would say, should probably be on your study sheet if I were you. If A and K, so let's highlight this whole box, right? This is like checking for understanding, and I will probably ask you that in some way, okay? But watch this. If A and K have the same sign, right? It's always about A and K, by the way. So if we have the same sign, something will happen. If A and K have opposite signs, something will happen, right? And if K is equal to 0, then you have another scenario going on there. And now let me explain why that is, right? If A is positive, right, that means it's pointing upwards. If K is positive, think about this part. You ready for this? If K is positive, that means that my vertex is above the x-axis, correct? If K is positive, so if your vertex is above the x-axis and it's pointing up, you're never going to cross the x-axis, right? It's gonna go up and never touch. So you can have, right, in a scenario like this, right? This is where A is positive and K is positive, right? So then it's just going up, never touching. On the other hand, if A is negative, right, it would be pointing downwards, and K would also be negative. So if K is negative, remember, what's K again? It's the Y value of the vertex, right? If it's below, then it's also never going to touch. So A negative, K negative, right? So in either case, the signs are the same, right? So if they have the same sign, that's what happens, right? So I don't know if you there. If they have opposite signs, that's when you're going to have two x-intercepts. So no x-intercepts coincides with this, never crosses the x-axis. Not crossing x-axis. That's basically what is being talked about here, right? If A and K have opposite signs, that's when you have two x-intercepts. So let's say A is negative and K is positive, then you'd be up here, right? K is positive, the Y value of that vertex is above, and A is negative, it'd be doing something like this. So A is negative, but K is positive in this case. So you have two x-intercepts there. On the other hand, if k is negative, then the vertex is below the x-axis, but a would be positive, right? And that would create this, where you have two x-intercepts. So here a is positive and k is negative. So they have opposite signs. So without even typing this into your calculator, you can foretell, you can tell how many x-intercepts there will be, right? And then the last scenario is when k is exactly equal to 0. Think about it. If k is 0, it doesn't matter what the x value will be. You are right on, right? So we can say this, right? In this case, a is positive, but k is equal to 0, right? You could still have one here where a is negative, right? A is negative, but k is still equal to 0. So sorry about that there. So in this case, we hone in. When in this case, everything kind of stops and says, hey, k is equal to 0. Doesn't matter what a is. I don't even care. It's just going to be on the vertex. So you only have that one, right? Just that one x-intercept in that scenario. Okay. So there's not much to it other than this, really. Like what I'm talking about now, that's the most important part about the vertex form. And now we're going to do a little bit of explaining and a little bit of calculating, and then we're done with this, okay? So let's say there's a question like this, and I will say without looking at your calculator, I don't know if you're going to do that, right? You might still want to do it, right? But I'm going to still expect you to explain, right? So then you're stuck anyways, right? Even if you're typing it in, you have to explain how you know, right? So how many x-intercepts are there? Explain, okay? No calculator, without calculator. So in this case, you notice it's a vertex form, right? Brackets, right? Vertex form in this case. Okay, so since A is negative and K is negative, the parabola will have no x-intercepts. You could have also said, since A and K have the same sign, there will be no x-intercepts. Okay. And if you so if you were to graph that, it just graphed it. It's just right there, but you can tell that it's never going to cross the x-axis. I don't need to even extend my window, right? That tells everything right there. Okay, next. I'm going to try and finish this before we go. Ooh, 5 minutes. 5 minutes on this here. So over here, the values of A and K are opposite. And then you can do this on the side. A is positive and K is negative. Therefore, the parabola will have two x-intercepts. Simple as that. So if you remember that, pop quiz, what if this exact same equation was just like that? How many X intercepts? It's just one, right? Because k is equal to 0, then it's just one. I will show you this anyways. I know you're already, like, your mind is somewhere else, but calculate the y-intercept algebraically. We have done this before. So basically, if you take the first one, what's x equal to when you're finding the y-intercept? 0. So you're going like this, right? You turn x equal to 0, and then you just clean it up like that. And that's negative 2. 4 squared is 16 minus 5. Y is equal to negative 32 minus 5. Y is equal to negative 37. So you, in fact, have found the y-intercept like that. Here's your homework. Notice that it says textbook. So finally, you can shake the dust off the textbook, and the answers are at the back, right?